welcome back to the channel, guys. So today we're gonna go ahead and get started on the build on the new Pilot RC 2.2 meter matrix. I did put the jet together, mocked up, and then just kind of wanted to see what the dry weight of this jet is straight out of the box as a turbine ready, with all of the servos installed, landing gears, and the brakes installed on this jet. So I put the jet on my Sequoia digital CG scale, and the overall weight of this jet without any of these components that's going to go in the jet came out to about 18.5 pounds. So not bad for a 2-meter jet. It's still relatively light. The goal on this build is going to be to basically build this jet as light as I can as possible. I am going to be flying this jet at sea level. So I think with this jet, I'm going with the King Tech 120. Now for a sport jet flying style, the Pilot RC recommends a turbine of between 100 to 140. So I'll be right in the middle of that power band recommended by Pilot RC. So hopefully it turns out pretty well. So let's go ahead and take a look at the table to see what components is going to be put on this jet, and then we can go ahead and get started on the build. Alright guys, so we've got pretty much all of the components that's going to be installed on the new Pilot RC 2-meter matrix. So pretty much from the left, starting with the receiver, I will be using 2 of the PBR 2060 receivers for redundancy. As far as the power management to the servo, I'm going to go with the tried and tested PowerBox Pioneer that I have been using on a lot of my jet builds lately. What I really like about this PowerBox is that it only weighs 1.5 ounces, and I was kind of hung up between the Pioneer and using the Mercury here that I have on the left. So the Mercury came out to about 3.6 ounces in weight. So granted, 2 ounces of weight is not a significant amount to add to the build, but being that the goal of this build is to keep it as light as possible, I'm gonna go with the PowerBox Pioneer this time on this build. And then for the power to the receivers, I will be using 2 of the AR Powers lithium-ion receiver packs, 2 cell, and there will be about 3200 milliamps per pack for redundancy. Now as far as power to the turbine, I'll be going with the Pulse 3800 milliamp life pack. And then for our retracts, we got our PowerBox, or I'm sorry, Pilot RC retract controller, and then we're going to be using the Asan AG68 no steering gyro with brake assist. Now as far as the turbine, being that I'm going to be flying it sport, the recommended turbine for that type of flying is 100 to 140 Newton turbine. So I decided to go with the King Tech K120 as my turbine for this build. So let's go ahead and get started on the build in the new matrix, beginning with the fuel tank cleaning. So we're going to remove the fuel tank and then make sure the plumbing is good, and then clean out the internals to make sure there's no residue during from the factory during the build. Alright guys, so I've got the fuel tank removed from the Pilot RC matrix. This is actually a very cool looking fuel tank that Pilot RC came up with. It is made out of Kevlar, and one thing that I did notice about the design of this fuel tank is that there's little grooves here on the top of the tank, so the Velcro straps locks it in place. And then also one thing that I want to point out to you guys, this is something that I did with all of my builds. I always remove the fuel tank and take a look at the fuel plumbing just to see how well the factory put it together. Now from the previous Pilot RC builds that I've done, the BAE Hawk and AF-16, I wasn't all that impressed with how the factory assembled the fuel tank and the fuel lines for the plumbing. So when I took this fuel tank apart just to take a look at the plumbing and to clean the inside of it, Pilot RC really stepped it up this time by actually putting clamps on the fuel fittings and the fuel lines. So The previous models that I built, Pilot RC models, it was just zip tied in place, and we all know that that's not going to last a very long time if it's just a simple zip tie that locks the fuel lines in place. But give you guys a closer look at it. These are actual clamping systems that Pilot RC installed on the Matrix. So big thumbs up to Pilot RC for really upping the game. Even just the most basic stuff like the plumbing in the fuel tank, they've actually took the time and improved on the product. So basically the fuel tank, I just poured some denatured alcohol in there, slushed it around just to kind of clean out the inside of any debris that may have been left inside during the manufacturing process of this fuel tank. And then now we're ready to install this back in the jet. Now I do want to say that it was quite a bit of a pain trying to get this fuel tank out. I had to separate the two-piece fuselage apart and then pull the fuel tank out. So this is one of those processes where you do it once and then you do it right the first time. You should never have to pull the fuel tank out because it is quite of a pain trying to get the fuel tank out. So let's go ahead and put this fuel tank back together, install it back in the Matrix, and then move on to the next section, which is installing the turbine in the jet. Alright guys, so I've got the fuselage pretty much in half right now, just to give you guys a look at the internals of this jet. So on the tail section of the Matrix, this is what it looks like on the inside. So I removed the thrust tube out and then just kind of routed the wires. I may actually put some heat insulation tubing on the wires just to make sure that I have ample heat protection to the wiring, and then I may use some aluminum heat shrink tape up here where the servo leads are, just to kind of give it some added protection there. So once I get done with that, I'll show you guys how it looks. I'll see you guys in a little bit. Alright guys, so something that I discovered while I was looking at the wires. Basically the elevator wires, and then here's your rotor wire that just runs up the tube and then goes all the way forward into the plane. But the two elevator wires running through that former, behind it is bare fiberglass. So I think what I'm going to do is insulate these wires so that as I'm flying, you know, they're not just kind of flapping around and then eventually over time the fiberglass cutting into the insulation of the wire and then causing problems later on. So I'm going to figure out what to do with that, and I'll show you guys in the end what I come up with. Alright, so it's going to be a little tricky for you guys to see, but basically what I did was I used some thermal tape to insulate the elevator servo wires, and then just kind of put a wire loom around it for the elevators, and then zip tied it to that former so that it doesn't move around while I'm flying. Then also I added some wire looms or heat insulated wire looms around the both elevators and the rudder, and then this is gonna basically route forward to the front of the aircraft, and then, you know, we're pretty much insulated from the heat back here. So we're ready to put the thrust tube back in and then put this jet back together. Alright, so we're pretty much done with the tail section of the Matrix. So pretty much all I did was insulate the wires and then put a marine heat shrink tube in there to keep it from sliding around. But basically this is ready to be put back together, and we're just going to bolt the tail section with the forward section of the fuselage with the included stainless steel 4 bolts. We'll do that next. Alright guys, so pretty much got the turbine lined up. We haven't drilled the holes yet, but with the KingTech K120 Gen 4, I measured out from the beginning of the thrust tube to the end of the exhaust cone. I went with the 1-inch distance for that. Originally started off at 3/4, but it just looked like the turbine is too far in the bell mount, so I moved it back another 1/4 of an inch, and this is where I'm at right now. So I'm pretty satisfied with the alignment, so I'm going to go ahead and start drilling the holes and bolt this turbine down. Alright guys, so we pretty much got the turbine lined up in the thrust tube, so I'm pretty satisfied with how it is lined up. So I'm going to go ahead and start drilling the holes and bolt this turbine down. Alright guys, so now that we've got the turbine installed and the fuel plumbing is almost complete, the last thing that I need to do is remove the factory UAT and then do a little bit of an upgrade. I'm going to take out the Pilot RC UAT and install the Inarco iTrap 40 in its place. So we'll do a little bit of a modification here. We're going to take the existing UAT out and use the existing formers and then somehow put a plate over it so that I can mount this UAT in its place. So I'm going to go ahead and get started with that, and I'll show you guys what the finished product looks like. Alright guys, so here is the finished product. Basically used the existing formers and just kind of modified it a little bit. I cut out a piece of Alutex board as the base of the tray for the UAT, and then just mounted the Inarco iTrap 40 in place. So it definitely looks a lot better than the factory UAT, and I am very satisfied with how it turned out. So now I can move on to finishing the fuel plumbing, install the fuel pump, and then we can move on to the electrical. Alright guys, so I pretty much just 3D printed a fuel pump mount that I also tapped in a 440 blind nut. So basically this is going to be high soldered in place right here in the center, right below the component tray, and then we're just gonna bolt it down. Once it's glued in onto the fuselage, it's gonna be bolted down by 440 bolts. And it's basically going to sit somewhere around right there, and then we're gonna put our Festo on and off ball valve right in this location so that I can easily access it to open up the valve for engine starts and then shut it off when we're done flying. So I'm gonna go ahead and high solder this in place and then show you guys how it looks in the end. Alright guys, so we are pretty much done with the fuel plumbing of the Pilot RC 2.2 meter matrix. So here we've got the iTrap 40 installed with the 6mm inner diameter Festo fuel line from the main tank into the UAT, and then from the UAT we got a 4mm inner diameter into a on and off ball valve, and then to the fuel pump, and then from the fuel pump to the turbine. Now I wanted to try to get this as clean as possible, so trying to figure out ways to get this fuel lines routed without making it looking like a mess. So I pretty much just used the existing formers here, and then I noticed that there was pre-drilled holes on the formers. So from the left side we've got a 6mm fuel line, and then I just pretty much put a rubber grommet on it to make sure that the fuel line is not rubbing up against the bare fiberglass and cutting into the fuel line. And then on the opposite end we've got the 4mm fuel line that goes to the turbine, and then also I put a rubber grommet there to basically prevent the fiberglass from cutting into the fuel line. So we'll take a look at the back section of the jet and then show you guys how the fuel filter and setup looks like going towards the turbine. Alright guys, so here is the tail section of the 2.2 meter matrix. So here we got the KingTech 120 Gen 4 installed, and then we've got the fuel filter installed right below the main fuel tank. So now that we are complete with the fuel system, we are going to go ahead and get started with the electronics of this jet. So I will see you guys in the second series of this build on the new Pilot RC 2.2 meter matrix.